This lesson is on dividing rational expressions. We're going to start again on this page by just doing a bunch of examples and talking through them, different types of examples. So let's do one. Let's say we have x squared minus 25 divided by, or excuse me, over 4x plus 28. Okay, and I'm going to divide that by x minus 5 over x squared plus 9x plus 14. Well, we have here essentially two fractions, which is what a rational expression is. So what I'm going to do is how I would typically divide regular fractions. I'm going to keep, change, and flip. Okay? So I'm going to keep the first fraction the same, the x squared minus 25 over the 4x plus 28. Change the sign, so there's the keep, change, and flip that second fraction. So I'm actually going to have x minus 5 on the bottom and x squared plus 9x plus 14 on the top. Now we're doing what we did with dividing or multiplying these rational expressions. Can I cancel anything out originally? No, but I can factor. Okay? So I can break down this first fraction. That's a special product. It'll be x plus 5 times x minus 5. This bottom on the first fraction, I can pull out a 4. I'm left with x plus 7. And this is being multiplied. I can't touch the x minus 5, so I'm going to leave it on the bottom. And I'm going to factor the top. It's going to be 7 and 2, x plus 7, x plus 2. And then I'm going to cancel out what I can. I have an x minus 5 and an x minus 5. I have an x plus 7 and an x plus 7. So now I got to see what I'm left with. X plus 5 is being multiplied still by this x plus 2. And it's all over. The only thing left on the bottom is 4. And that's my answer. All right, let's do another one. Let's do 3x squared minus 12x over 5x and divide it by x squared minus 3x minus 4. Okay, so now I actually have to make this first one into a fraction. And now I'm going to keep, change, flip, because now I've got those two fractions. Keep, change the sign, flip the fraction. So I have the 3x squared minus 12x over 5 times 1 over x squared minus 3x minus 4. Factor out what you can. I can pull a 3x out of this. And I'm left with x minus 4. And on the bottom, I can't touch that 5. Being multiplied by, can't do anything with that 1. And factor the bottom. It's got to multiply to negative 4, add to negative 3, x minus 4, x plus 1. And then cancel out what you can. I can cancel the x minus 4 and the x minus 4. And I can, oh, yep, that looks it. That looks like it's it. So we're going to have left then this 3x times 1, which is just 3x, over, this is just a 5, and I'm left with x plus 1. I will say too, if this had an x here, this, even though I can't cancel out a 3 and a 5, I can essentially cancel out these x's because there's one on the top and one on the bottom. Okay, and if you come across that, you can cancel those out. All right, and the next problem that we're going to do is going to be a little bit different. We're going to call this a complex fraction. You won't have any of these on your left-hand page, but you do need to be familiar with them. It's a complex fraction. Okay, so what is this, number 3? All right, a complex fraction has one or more fractions in its numerator and its denominator, or both. That definition's in your vocab. So it's going to look something like this. We have 1 over x minus 2 over, or divided by, x plus 3 over x squared minus 4. Okay, so essentially I have a fraction here and a fraction here. And the operation between them is division. So that's what I'm going to do. We're going to write it as a quotient, excuse me. Okay, so that leaves me, I'm going to put my first fraction first, 1 over x minus 2 divided by x plus 3 over x squared minus 4. And then, as the same with above, I'm going to keep, change, and flip. So keep 1 over x minus 2. And I'm going to multiply this by x squared minus 4 over x plus 3. I'm going to need to factor out this top one, which would be, let's go over here, 1 over x minus 2 times, that's a special product, x plus 2 and x minus 2 over this x plus 3. Cancel out what you can. 1 times this is just itself, so I'm going to leave it. I have x plus 2 on top, and x plus 3 is the only thing left on the bottom. That is what it reduces to. Okay? All right. So, on your left-hand page, you are going to do the evens. Make sure it's the dividing the rational expressions. You're going to do the evens, okay? Give it your best shot. The code word for this lesson is prince.